Hi guys, today we are studying the subject heterocyclic compounds. Definition: heterocyclic compounds are organic compounds that contain a ring structure containing atoms in addition to carbon such as sulfur, oxygen or nitrogen as their heteroatom. The ring may be aromatic or non-aromatic. Significance: two-thirds of all organic compounds are aromatic heterocycles. Most pharmaceuticals are heterocycles. Heterocycles are important, and a large proportion of natural products contain them. Many pharmaceutical and agrochemical contain a list on heterocyclic units. Heterocyclic systems are an important building block for new material processing. Interesting electronic, mechanical, or biological properties. Heterocycles contain one or more heteroatoms in a ring. Heterocycles X, Y, Z are usually oxygen, nitrogen, or sulfur. Consider some examples of heterocyclic compounds that are found in nature. Nicotine. Present in tobacco, nicotine has two heterocyclic rings of different sizes, each containing one nitrogen. Adenine. One of the four heterocyclic bases of DNA, adenine contains two fused heterocyclic rings, each of which containing two heteroatoms nitrogen. Penicillin. One of the most widely used antibiotic, penicillin has two heterocyclic rings, the smaller of which is crucial to biological activity. Coumarin. Found in clover and grasses, coumarin produces the pleasant odor of new mown hay. Alpha-tritionyl. This compound with three-linked sulfur containing ring is present in certain marigold species. Cantharidin. This compound, an oxygen heterocycle in the active principle in Cantharis, also known as Spanish fly, a material isolated from certain dried beetles of the species Cantharis vesicatoria and incorrectly thought by some to increase sexual desire. Classification: aromatic six-membered, isoelectronic six-membered carbocycle, benzene uncondensed cycle correspond to one or several heteroatoms. For example, one heteroatom, pyridine, and beryllium salts, which contain one oxygen atom, as well as six-membered ring that contain two heteroatoms, pyridazine, position 1 and 2 nitrogen atom, pyrimidine, 1 and 3 position heteroatoms, and 1,4 position atom nitrogen, name compound pyrazine. Naphthalene is isoelectronic analogues to quinoline and isoquinoline. Classification: aromatic 5-membered. Cyclopentadienyl anion is isoelectronic analog 5-membered aromatic compounds. As an example, the following heterocycles: pyrrole, furan, thiophene, imidazole, oxazole, thiazole, pyrazole, isoxazole, isothiazole, and 1H indene 1-ite anion is electronic analog indole. Example, chemical formula indole. Heterocyclic compounds classified by saturation. This substance may be saturated or unsaturated. Unsaturated heterocycles may be aromatic resonance structures. For example, For gamma pyrrole, product can be aromatic dipolar resonance form. Also, 2-pyridine is convertible to an aromatic dipolar resonance form that is stabilized in 2-hydroxypyridine, isolated as unsaturated heterocyclic compounds. For instance, ethylene oxide, tetrahydrofuran, 1,4-dioxane, pyrrolidine. Pyridine has a structure similar to the all-benzene except that one CH unit is replaced by a nitrogen atom, as with benzene. Pyridine is a resonance hybrid of Kekulé-type structures. The orbital pictures for benzene and pyridine are similar. The nitrogen atom of the carbons is sp2 hybridized with one electron in a p orbital perpendicular to the ring plane. Thus, the nitrogen contributes one electron to the 6 electrons that form the aromatic P cloud above and below the ring plane. On the other hand, the unshared electron pair on nitrogen lies in the ring plane in an sp2 orbital. Because of the similarities in bonding, pyridine resembles benzene in shape. It is planar with nearly perfect hexagonal geometry. It is aromatic and tends to undergo substitution rather than addition reactions. Another reason is that pyridine is much more polar than benzene. The nitrogen atom is electron wave driven compared to carbon. Hence, there is a shift of electrons away from the ring carbons, and toward the nitrogen, making it partially negative and the ring carbon partially positive. This polarity enhances the solubility of pyridine in polar solvents like water, and also increases the boiling point of pyridine, 115 degrees Celsius, relative to benzene, 18 degrees Celsius. Pyridine is weakly basic. Pyridine does react with strong acid to form pyridinium salts. For this reason, pyridine is often used as a scavenger in acid-producing reactions. For example, in the reaction of thionyl chloride with alcohol, etc. The term alkali-like is commonly used to designate basic heterocyclic nitrogenous compounds of plain origin that are physiologically active. The name alkaloid comes from the Arabic word for ash. Alkali alkaloids are a group of naturally occurring chemical compounds that contain mostly basic nitrogen atoms. This group also includes some related compounds with natural and even weakly acidic properties. Some synthetic compounds of similar structure are also termed alkaloids in addition to carbon, hydrogen, and nitrogen. Alkaloids may also contain oxygen, sulfur, and more rarely other elements such as chlorine, bromine, and phosphorus. So, basically, alkaloids are naturally occurring nitrogenous substance which is isolated from plants and react like bases. Deviation from definition. Basicity. Some alkaloids are not basic, e.g. colchicine, piperine, quaternary alkaloids. Nitrogen. The nitrogen in some alkaloids is not in heterocyclic ring, e.g. ephedrine, colchicine, mescaline. Plain origin. Some alkaloids are derived from bacteria, fungi, insects, frogs, animals. Biosynthesis. Some alkaloids are not derived from amino acid, e.g. purine steroidal alkaloid. Chemical properties. Most of the alkaloids are basic in nature due to the availability of lone pair of electrons, one nitrogen. The basic character of the alkaloid compound is enhanced if the adjacent functional groups are electron releasing. The alkaloid turns to be neutral or acidic when the adjacent functional groups are electron withdrawing like amide group, which reduces the availability of the lone pair of electrons. Their salt formation with an inorganic acid prevents many at times their decomposition. In the neutral form, the alkaloids exist either in free state as amine or as salt with acid or alkaloid anoxide. The alkaloid may contain one or more nitrogen and exist in the form of primary amines, norephedrine, secondary amines, ephedrine, tertiary amines, e.g. atropine, quaternary ammonium salts, tubocurarine. The pyridine ring can be fused with benzene rings to produce polycyclic aromatic heterocyclics. The most important examples are quinoline and isoquinoline, analogues of naphthalene but with an nitrogen in place of CH at C1 or C2. Electrophilic substitution in these amines occurs in the carboxylic ring, illustrating the inactivity toward electrophilus of the pyridine ring relative to the benzene ring. The stability of the pyridine ring is also illustrated by its resistance to oxidation. Thus, when quinoline is treated with potassium permanganate, the benzene ring is oxidized. The quinoline and isoquinoline ring occur in many natural products. Good examples are quinine, which occur in cinchona bark and is used to treat malaria, and papaverine present in opium and used as a muscle relaxant. It is logical to ask if we can replace one CH with nitrogen in a benzene ring to create pyridine. Can we replace more than one of the benzene CH group with nitrogens? The answer is yes. For example, there are three diazines of these. The most important are the pyrimidines, derivatives of which cytosine, thymine, and uracil are important bases in nucleic acids, DNA, and RNA.
Lactam-lactim rearrangement. They exist in two tautomeric forms. Only the lactam forms can be ribosylated to give nucleosides.
Consider lactam-lactimic tautomeria on specific examples. Thus purine-based guanine in two forms, lactam and lactimic. Lactam group and the cyclic amide group has a movable proton on a nitrogen atom. This hydrogen atom is able to convert to the oxygen atom of the carbonyl group, which result in the formation of a lactimic form that is characterized by the favoring of the pyrimidine cycle and the presence of the hydroxyl group. Similarly, the pyrimidine-based thymine is capable of being in the lactimic form. It should also be noted that in pyrimidine type molecules such as uracil and thymine, two lactimic forms are possible due to the fact that there are two endocyclic amide fragments in the composition of these structures. As a result of this kind of tautomerism, it is possible to form 2,6-dihydroxypyrimidine and 2,6-dihydroxy-5-methylpyrimidine. Consider this phenomenon in more detail. The amino group is capable of being converted to an imino group if vicinally contacted with a double bond, thus by the acceptor action of the nitrogen atom on the hydrogen atoms in the amino group. Their mobility is increased and they are able to migrate to the beta position at the multiple bond site. As a result, an imino form is formed. A reverse process is also possible where the electron density depleted hydrogen atom migrates imino group. This results in the formation of an amino form. These processes are in equilibrium. Purine bases are also known to undergo amino-imine tautomeria. For example, in adenine mobile hydrogen atoms are able to migrate to the nitrogen atom of the pyrimidine cycle. Its amino form is formed. Similarly, cytosine can also form an imino form. However, the equilibrium is highly shifted towards the amino form.
The purines are another biologically important class of fused ring heterocycles. They contain a pyrimidine ring fused to an imidazole ring. Uric acid is present in the urine of all carnivores and is the main product of nitrogen metabolism in the excrement of birds and reptiles. The discus gout results from deposition of sodium urate, the salt of uric acid, in the joints and tendons. Caffeine present in coffee, tea and cola beverages and theobromine in cocoa are also purines. Perhaps the most important purines in nature, adenine and guanine, two of the nitrogen bases that are present in nucleic acid, DNA and RNA. Many nitrogen heterocycles play a role in medicine. Nucleotides are phosphate esters of nucleosides. A hydroxyl group in the sugar part of a nucleoside is esterified with phosphoric acid. In DNA nucleotides, either the 5 or the 3 hydroxyl group of 2-deoxydeiribose is esterified.